heck is going on? And so tomorrow, am I doing all 6 also? The last 6?
Yeah.
Kind of sad.
Are we on it?
What?
We're on it.
Yes, we're on there. It's 16. What are the dimensions of the lightest open top? You gotta read carefully now. Open top right circular cylinder. Cylindrical can that will hold a volume of 1,000 cubic centimeters. Did you guys look at the diagrams I drew too on the website? Okay, so call this X, call that Y, or whatever letters you want to use. Now, what are we trying to maximize and minimize in this problem?
Weight.
Which is directly proportional to the surface area.
Surface area.
Surface area. So what is the surface area of this can? Holmes.
Hang on, let me look it up.
No, it's a cylinder.
Oh. Oh yeah.
You don't need to. You better not have to look up this one.
D pi h.
What? First of all, I don't see any D or H here.
2xh then. 2x pi h. The circumference of the circle times the. Well, I don't know, whatever.
2 pi x y, you mean?
What? Yeah.
Plus.
I don't know. It's an open top, so the bottom.
So get 1 on the bottom.
What half can?
X squared pi.
I guess that's correct. Okay, but the problem is got 2 variables. You got to get rid of one of these variables. That's why you need another equation. Emin, what's the other equation?
The one with the number it gave. Sorry. I'll open up my book.
And so how do you use it? The volume of this can is 1,000 cubic centimeters. Come on, volume of a cylinder.
So pi x squared times y equals the 1,000.
The number they gave.
Yeah.
And there you go. So all you gotta do is solve for one letter in this equation and plug it in here. So y is easier to solve for. Y equals 1,000. Oh, do you guys notice every problem is like the same? You just gotta practice it, man. Plug it in there. So you get 2 pi x y, which is 1,000 over pi x squared plus pi x squared, and then simplify. So you got 2,000 over x plus pi x squared. Oh, this one will come out ugly. Okay, how do I, now you gotta simplify this. So you make a least common denominator. I bet some of you not making least common denominator. So 2,000 plus pi x cubed. Can't factor that. We are ready for the number line. Zhang, what goes on the number line besides 0? Oh, we got, yeah, what the heck are we doing? We haven't take the derivative yet. Then why are we making that? So dumb. A prime equals, Zhang, derivative.
Negative 2,000 x to negative 2 plus 2 pi.
Okay, and then now we make a least common denominator. So 2 pi x cubed minus 2,000. And I guess all we can do is factor out a 2. So you get pi x cubed minus 1,000 all over x squared. So when we make our number line, woo, 0, what else is on the number line? To go. Since you just started working on it now, it should be there.
Is it the cube root of 1,000 over pi?
Mm-hmm. Which simplifies to?
Plus your
Mhm.
plus 1,000 over.
Okay, let's write that down. Cube root of 1,000 over pi. That is correct. But you can, come on, cube root of 1,000.
10 over the cubic root of
The
pi.
cubic root of pi.
Yes.
Alright. And then if you plug in a number bigger than that, it's going to be plus, and then over here it's going to be minus, correct? And again, over here would be minus, but we really don't care over there because this is a, right, x cannot be negative. So we got the surface area is decreasing here, the surface area is increasing there, so the minimum occurs here. So x max is equal to 10 over the cube root of pi. Huh? Yeah, it is min. Check the video. And then you guys answer the question. I don't know what the question is. You guys gotta at least do that part. So make sure you know all your formulas now. Cylinders, cones, and spheres. Well, whatever comes up in the homework, which will be all of that. Okay, next. 17. Designing a can. Okay, so this is like the same thing except different. You got a can here. And why don't we call that x and y? Anyway, on the quiz, I'll give you a diagram for each one, and I'll put in the variables so everybody uses the same variables. You're designing a 1,000 cubic centimeter right circular cylindrical can. That's the same thing. There is no ways. So do you guys even understand this problem? Okay, what are we trying to do in this problem? We're trying to minimize, what are we trying to minimize in this problem? Saito. Paulo, you know you're next, right? What are, you're not even following along? Wow, your lips aren't moving, but I could hear something. We're trying to minimize what?
Sorry.
No. Look, number 7. It says, the surface area, or the amount of material that you're going to use. Okay, so let me ask you this. Look at this. How much material am I going to use here? It's like the,
Is it the one given in the problem?
yeah, so tell me.
8r squared plus 2 pi r.
Except I'm using x instead of r. 8x squared plus
2 pi xy.
2 pi xy. Now, of course, if you're not reading the problem, you're going, how come it's 8x squared? Shouldn't it be pi? You got a circle on the bottom and a circle on the top? How come it's 8x squared? Paulo? Maybe if we read the problem, we would know. Yeah, but then you gotta know where that kind came from.
Square.
Yeah, why? Okay. If you read the problem, instead of cutting, this is like a real life problem. See, instead of having a circular thing for the bottom, they have to cut it out from a square piece first. So you actually have to buy this square piece, and then you're gonna cut out the circle. So this, you're gonna have waste, but you still have to pay for the square. You know what I'm talking about? So since the radius of the thing is x, isn't the side of the square 2x? Therefore, what is the area of the whole square? 4x squared. And since you have one for the top and one for the bottom, that's why it's 8x squared. Oh, so Mr. Park, we really got to read the problem then. Yes! But again, notice that there's 2 variables. We need another equation. And what's the other equation? The volume is 1,000 cubic centimeters. So what is the volume of this can? Pi x squared y is equal to 1,000. Solve for y. People, like you told me before, the hardest part is writing this function right here. So you guys gotta practice. You copy off the board, that ain't no practice. So you got 8x² plus 2 pi xy, which is equal to 1,000 over pi x². Okay, this one will come out much nicer, because the see over there, the pi's cancel out, that's why. And that x cancels that x. So we get 8x² plus 2,000 over x. Take the derivative. So this one's easy. 16x minus 2,000 over x². Have we memorized the derivative of 1 over x is negative 1 over x² yet? Make a factor it. Shoo! So we got 16x³ minus 2,000. Does 16 go into 2,000?
Yeah.
How many times? 125. So x³ is equal minus 125 all over x². And look how nice that is. So when you make your number line, woo, you got 0 and 5. And then plus, minus, and then, well, this one's minus, but we don't care. So the area is decreasing here, then it's increasing there. There is a minimum at 5, so x min is 5. So see, on my quizzes and tests, I like to make the answers come out nice like that. So if you're getting something ugly, that's kind of like a hint you're doing something wrong. Although, you know what? This year, maybe I'm going to make one of the 3 come out ugly just to keep you honest. Like this one, cube root of 10 over the cube root of pi, just to keep you honest. Okay, next, number 20. Okay, now on this problem, did I put on the thing you can use a graphing calculator? Before, we never used to use a graphing calculator, but because it came out ugly, but you guys could actually handle it. Do you guys remember this problem from last year's pre-calculus book? Jane is 2 miles offshore. So here's the beach right here, like this. And you want to reach a village 6 miles down the straight shoreline. So here's the village over here, and this is Jane. She wants to get from there to there. This is 2 miles. Now, this is the water. She's in the water now. She can roll 2 miles an hour, but she can walk 5 miles an hour. Where should she land her boat to reach the village in the least amount of time? So shall she just row straight for the village? No, because she can walk like over twice as fast as she can roll. So probably the strategy is you're probably going to roll somewhere over here and then walk the rest of the way, right? So that's what you're trying to find. Where should she aim her boat? So this is the way, if you look at the diagram I gave you, that's x. And if the whole thing is 6, what is from here to here then? 6 minus x. And if you use the Pythagorean theorem on this triangle, what's this? Square root of x² plus 4. Okay, now what are we trying to maximize or minimize in this problem? The time. Okay, now remember, rate times time equal distance. Time is equal to distance over rate. So the total time is going to be the time that she spends rowing plus the time she spends walking, right? I'll call that capital T for total time then. So how do you figure out the time she spends rowing? Well, it's going to be the distance that she rows divided by her rate. Well, what is the distance that she rows? No. I got it right there. This is the distance that she rows, and then you gotta divide that by her rate. 2 miles per hour. Plus, what about the distance that she walks? 6 minus x over her walking rate, which is 5 miles an hour. So this is the time that she spends rowing, this is the time that she spends walking. You add them together, that's the total time. So this is what we want to minimize. So first step, we take the derivative and make sure we take it correctly. Whose turn is it? Holmes. Okay, look, this is like 1/2, and that's like to the half power, right?
1/4 times root. Yeah.
Walks to the half.
is 1/2 x. Never mind. Root x squared plus 4. 1/2 x.
Yeah, but then when you times the half, you get a fourth, right?
Yeah.
Okay, then you get box to the,
-1/2 times x.
okay, and then if you lift and separate this one, it's a lot easier, like see. If you write it like that, it's easy to figure out the derivative of that what. Because a lot of people want to use the quotient rule on this, but no need. So what is it? 0,
-1/5.
-1/5. Anyway, if you use the quotient rule on that, you can get -1/5 anyway. There you go, that's the derivative now. Before, we used to just simplify it, and it came out, had like a radical 21, I think, or something, but what the heck, let's practice doing this on our calculator. So you graph this on, I'm not gonna do this part now. Graph this on your calculator, and my guess is it's gonna look like, we're looking for a minimum, right? My guess is the graph will look something like that. So there's a place where it crosses the x-axis, I don't know what that is, and then it's below, and then above. So that means time is decreasing, time is increasing. So the minimum time occurs right there. So T min, X min rather, is equal to whatever that number is, and then answer the question. I think last year on the quiz, I gave the same problem. All I did is, what's the only thing I changed? Instead of the whole distance being 6, no, I think I did 6 and 2. I just changed the rowing rate to 3 and the walking rate to 6, and then something like that. All hell broke loose, I remember. 21. Oh, this is like the one we did. I believe this one too, right? You get to use your calculator. So here I have a cosine graph that looks like this. This is y equal 4 cosine of 1/2 x. So I'll just put x over 2. From -pi to pi. And then you're going to put, probably this is going to be one of the 3 problems. Find the area of the rectangle. And here's the point xy. I'll give you a picture like this. What are the dimensions of the rectangle with the largest area? So we're trying to maximize the area. So looking at this picture, what is the area of the rectangle? 2xy, but again, you got 2 variables, but then y is already given, so just plug it in. So 2x times y, which is 4 cosine of x over 2, and then let's simplify that, 8x cosine x over 2. Then you take the derivative. Who was next? Emmons, derivative.
8 times, negative sine, oh,
You gotta use product rule, man.
can I throw it on the side?
What?
Huh?
Derivative of the first, right?
Okay,
That's what you did, right?
yeah,
Okay.
8 times cosine x over 2, plus 8x times negative sine, x over 2, times 1/2.
Times 1/2 times the derivative
Yeah.
of box. You don't multiply by derivative of box, it's like 4 out of the 6 points gone already. Okay, graph that on your calculator. Of course, I would gussy it up a little, like I would do this. So what is that? Negative, so that's a minus 4x sine x over 2. So I would simplify to that, graph that on your calculator, and my guess is it would look like this, minus, plus. And so, you graph this on your calculator, it's gonna look something like that. But just make sure you make x min 0 and x max pi, right? Because this point has to be somewhere over here, right? Because if you just graph it, you're gonna see this. You can see lots of answers. But this problem only makes sense if this point is between here and here. So you should make x min 0 and x max pi. And then over here, area is decreasing, area is increasing. So the minimum occurs here. I think you can take it from there, I hope.
Just a part.
Yeah.
It's asking for the maximum.
Oh yeah, what the heck am I doing? That's the third mistake I made today already. Well, at least somebody's paying attention. So it should be, the graph looks like this then, if you graph it. So it's plus minus, so it's increasing, decreasing, so the maximum occurs right there. Let's see if I can go for 4.
Wait, Mr. Park,
Yeah.
when they ask for like the area, do you plug in?
So once you get this value of x,
You
just plug it
in
back.
all the numbers
Just-
or just?
yeah, all the decimal places. So you know when you, on your calculator, you know when you calculate this point right there? That point is now stored in x, so all you gotta do now, on your calculator, just punch in this. 8x cosine x over 2. And that's gonna be the area right there, right? Because this is the area, right? But if I were me, I would ask, find the coordinates of this point. That will give you the maximum. That's what I would ask. So once you get the x value, which is, you know, this value right there, how do you find the y coordinate of this point? Where would you plug it in? Yeah, that. This is the y coordinate. This, don't plug it into this. This gives you the area now. Plug it into that. That gives you the y. With all the decimal places now. We got 21. Oh, we got 2 more to go. 22. Hey, we're on the second page. That means the problem's getting harder. Find the dimensions of a right. Go to your room. Didn't we do this as an example? Remember the very first day we did this? Is this familiar? Didn't we do this? That's okay, I'll do it again. Why should I be surprised? Yeah? The sphere has a radius of 10. Where do I draw in the radius of the sphere to help me solve this problem? Remember? You draw it right there, because then you have a right triangle form. This is 10. Now if you remember anything, should I label this x or that x? Because I'm not going to tell you on the quiz. If you label the wrong one x, then too bad, you're going to get one ugly function to take the derivative of. But if you do it, if you pick the right one, then you get a polynomial to take the derivative of, which is way easier. This one x, A or B?
B.
Okay, good. Why do I label that x? Because when you use the Pythagorean theorem, then this side is going to be the square root of 100 minus x squared. Now, why do you want this one to be the radical expression? Because you can square it. So the volume of this cylinder is pi times the radius squared times the height, which is, what's the height of the cylinder? 2x, see? It's a polynomial. But then if you switched it, then you would get it, but it'll come out, except your derivative is going to be way more complicated. So, watch what I do. Didn't I do this last time? You see this 2 pi? I factor out the 2 pi, and then you get 100x minus x cubed. I factor out the constant, because aren't you going to factor it out anyway before you make your number line? I factored out the 2 pi, but then take the x and distribute it in. Or is that too confusing? Should I just multiply it out? Because then I'm going to factor it out later anyway. Okay, let's leave it. So when you take the derivative, see how you throw the constant on the side like an unwanted pet? What's the derivative of this? 100 minus 3x squared. Ah, ugliness. So when you make your number line, what goes on the number line? Plus or minus, which is, what's the square root of 100? 10 over root 3, negative 10 over root 3, and it's going to be minus plus minus, but we really don't care about that side because x cannot be negative. In fact, in order for this problem to make sense, x has to be between 0 and 10. Anyway, so over here, the volume is increasing, the volume is decreasing, maximum volume occurs right there. So x max is equal to 10 over root 3, and then you answer the question. I think I gave this problem last year too, except I changed that to 12 or something. Doesn't matter, right? You just do the same thing. And finally, the last problem. 25. Okay, shipping packages. So you got a box, you want to mail a box. This is for real now. This is like a real problem. The U.S. Postal Service will accept the box for domestic shipment only if the sum of the length, this is the length, and the girth is the distance around the box, does not exceed 108 inches. What dimensions will give a box with a square end the largest possible volume? Now, if you look at the diagram, did I draw a diagram for this too? Never mind, I'll just do it then. There. Draw the picture like, because I figure if I'm giving this on the quiz, I'm going to give you this picture right here. So we are trying to maximize the volume. What is the volume of this box? This is easy. X squared y. But we got two variables, so we got to get rid of one of them. We need another equation. Well, it says the sum of the length and the girth cannot exceed 108 inches. That means the biggest it can be is 108. So what is the length? Y. What is the girth? The distance around the box, like this. No, the girth, the distance around the box. So, it's 4x. That has to equal 108, right? Now, easy, solve for y. See, this one is actually easier. And then plug it in there. So, if I were you, I'd be paying attention. Instead of snickering. Oh, he said girth. You guys are babies. And then what do you want to do? Product rule or multiply it out?
Dude, we're on video. Come on.
I'm trying to keep a straight face, but I can't. Product rule or multiply it out? What? Are you serious? I would multiply this out. 108x squared minus 4x cubed. So the derivative is equal to 216x minus 12x squared. Does 12 go into 216?
Yes.
Okay, so 12x can be factored out. What's going to be left? Just read it off the paper.
18.
18 minus x. So when you, oh, this one's so easy. So 0 and 18 go on the number line, plug in a number bigger than 18, minus plus, and we don't really care over there, right? So that means over here, the volume is increasing, the volume is decreasing. There is a maximum volume when x is 18. So x max is 18, and then answer the question. So childish, you guys.
Wait, what's up with you?
What's your name? Okay, now tonight's problems. These are the 6 hardest problems. So if you didn't get practice, it doesn't matter because I'm going to do them all tomorrow anyway, right? Wait a minute! Oh, so if we have the quiz Wednesday, that means it's going to be on the first 3, then it could be any 3 out of the 18 problems then. But if we have the quiz tomorrow, it'll be only on the first 12 problems. No, we're going to keep it on Wednesday. Usually we do it like just the first 12, but then since you're making me do them all anyway, what the heck. Okay, we're done? We have 11 minutes left.
Are you posting?